We have made a tester for the batteries from hybrid and electrical vehicles. Here we have two batteries. This is the nickel metal hydride battery from the Toyota Prius from 2012 year of production. This is the lithium-ion battery, but I can say that this is one of the modules of the battery. This is from Hyundai Tucson Hybrid. It is also a hybrid vehicle, but it consists from a few modules. The battery consists from a few modules. We have developed a tester for this kind of batteries. First of all, we developed it from the nickel metal hydride batteries, and then we added a feature to test lithium-ion batteries. This tester have 36 channels, so you can connect separately 36 cells of the battery and test the capacity and make the balancing. This is very important for the car. If the car have disbalanced battery, it lose its range and it can go not far as it was developed originally. So the tester, we have 36 channels and we have connected only 20 of them. So we have free 16 channels. We can connect more cells. This battery contains only 20 cells, so it's enough to connect all of them like this. All of these channels, they are isolated from each other, so you can connect, for example, two channels to one cell to make the process faster. You will double the charge current or discharge current, and by this you can make the process faster by double. Here in the menu we can see all the modes that we have for lithium-ion batteries and nickel metal hydride batteries. So we have the charge and discharge feature. In the charge we will charge the battery. It is very important to set the compatible parameters for the battery. We can check these parameters in a data sheet on the battery, so you can try to search for some numbers or by the model of the car, and you will see the parameters of the battery. You can set it in the mode of the tester. The maximum charge current of the tester is 4.5 amperes. And maximum discharge current it's 6 amperes for each kind of the battery. Also, the very important mode here, it is test cycle. Test cycle we have for both nickel metal hydride and lithium-ion batteries. And in a test cycle you can adjust the steps which tester will do automatically. So you don't need to switch these modes by your hand. It will do it automatically. For example, you need to check the capacity of this battery. You will set first of all discharge of the battery. Second step, charge the battery to a 100% of state of charge. Then the tester will go automatically to a discharge if you set it in a test cycle. And by this way the tester will check the full capacity automatically, switching the modes automatically, so you don't need to pay attention on the battery and on the tester. Also, the tester have a lot of safety features. It has temperature sensors that you can see in the battery. They are installed in the battery, and if the battery starts overheat or something goes wrong, the tester will turn off the test. Also, we are using the delta voltage type of charge for the nickel metal hydride batteries, a very common mode for charging, and it is also one of the most important things in a safety way. We can charge this battery in a safety way by delta voltage mode. Also, for the nickel metal hydride batteries we have a trickle charge mode. The trickle charge allows you to make the battery charged for a 100% state of charge, because if you charge it only for the voltage of the charged cell, you cannot say by the voltage if it has 100% of state of charge or it has less. So for the nickel metal hydride, it's very important to use a trickle charge. For the lithium-ion battery, we are using a standard direct current and direct voltage type of charge. It is also very common, and we charge it to 4.2 volts commonly, because this is the maximum voltage for lithium-ion batteries, and we know that it is charged and we can stop the process. Also, this tester have the history result. It write the information each second of the test about all the cells which is connected. So you can see after that, after you get the result from the tester, you will see the diagram of charge, of discharge, and you can see which cells are bad, which are good. You can compare the capacities. Everything you can do on your own PC. We give you additional software for this tester for PC. After that, we have a liquid cooling system inside, so it is cooling good while working. Also, sometimes in very hot conditions, we can add additional fan. It's a standard fan for the battery, only for the battery, to cool it down by the air. We don't need any additional tools. This is our tester, the technical specification. You can check on our website, and now we will show you how to test two of these batteries. We will connect them properly, we will set all the correct parameters for them, and we will make the capacity test, and after that we will examine the results and see which cells are good and which are bad in these batteries. We connect a nickel metal hydride battery. In our case, we have a battery from 2012 Toyota Prius. In this battery, the modules consist of 6 individual cells connected in series. The nominal voltage of each cell is 1.2 volts. We attach them firmly to each other. This is how safety is maintained. You can check the charge level for each cell with a multimeter. It will always be the same if the battery has just been removed from the car and is in good condition. The difference will show you that there is already some imbalance. Connect the battery to our tester and check the capacity of each battery module. It's simple. Follow the polarity. Red is plus, black is minus. The polarity is usually indicated on the cells themselves, but sometimes not. So, if you reverse the polarity, nothing bad will happen. But the readings will be wrong and you will notice it immediately. Connect a temperature sensor to each cell. This will allow the device to monitor temperature in them, and you can see everything on the screen. Each channel to each separate module. We have all our contacts connected. To test nickel, it is best to repeat the discharge and charge procedure several times. That is, use a few cycles. This is ideal for more accurate results. So now we select the battery type in settings. For each type of chemistry, we offer 4 procedures: charge, discharge, cycle, and balance. For example, we choose nickel, and the testing is cyclical. We offer all the cell types we know. However, if you come across an unfamiliar one, you can always set the settings individually. We choose our type 6S, and here you can set the settings for the cycle: discharge, pause, to let the battery cool down a bit, charge, and so on. The 9th step is discharge, and here we get the capacity of each cell. Stop the process. Now we are going to discharge the battery. We are going to start the discharging process again. And we see each channel, the cell temperature and channel number at the top, voltage, the status of the channel. At the moment, it is still disabled. The reason for the shutdown or the readiness indicator will be displayed there. Capacity in ampere hours and the animation of the process. In discharging, there are a few settings: current and voltage. You can change them as needed. Save. Start the process. We see how much capacity we have taken from it at this point. During battery use, some batteries may discharge or charge unevenly. For example, one battery may remain undercharged while another battery may be overcharged. This uneven battery condition can lead to problems, such as reduced battery capacity or shortened battery life. This can be caused by several factors. If you have any questions about checking batteries or working with the MS800 tester, please take a look at our battery course, which you can find at the link in the description. We see how the indicators change. Now we have reached the minimum voltage for some cells. We are waiting for all of them to reach their discharge parameters. The U-mean indicator is the voltage limit to which we discharge the battery or cell, and here we can see its capacity. Right now, this data won't tell us much because it is only the first stage. Enter the charge mode. Charging mode for nickel-based batteries is a little more complicated than discharging and even more complicated than working with a lithium battery. So, go to the settings. We set the current, the maximum. These cells can handle this load without any problems. We leave the voltage the same. Leave the delta at the minimum value. Timeout is after the delta stop and before the trickle charge is activated, if you have activated it. If you don't activate it, it won't switch on. We activate it to fully charge each cell with maximum capacity. Low current for 20 minutes. This is enough to charge the battery. During trickle charge, the temperature drops slightly. If you see that it continues to heat up, it is better to stop. This will indicate that the battery cell is full. Save it. Start the charge. Here you can see the cell where the delta appeared and the trickle charge was started. This type of charge have blue indication, and now more modules have trickle charge activated. And now we can already see that most of the channels are already maxed out. U max is the maximum voltage limit to which we charge the battery or cell. And here we can see its capacity. We are waiting for other cells to charge. There we have reached the maximum value. That is, the battery is fully charged. We turn on the discharge again, and then we'll see the results. We can see the U-mean readings with the voltage limit appear. Now the cells are fully discharged and we can see the readings. Some cells have a much larger capacity than others. All data is stored in the system, so when all the processes are complete, we can transfer the data to a USB drive and view it on a computer. Now we will disconnect the nickel and connect the lithium-ion battery from the Hyundai Tucson Hybrid. The nominal voltage of lithium-ion cells is 3.6 volts. Disassemble the entire battery module and connect each individual cell to a separate channel. We check the voltage. It should reach 0, because now the cells must be disconnected so that we can disassemble the battery. Check the voltage on this battery as well. Remember that this type of battery has a series connection, so from minus to plus of next cell. Connect it to the tester. With this type of battery, you don't need to place temperature sensors in each cell, just at the beginning and at the end. Always remember how you connect the cells to the tester to understand which cell is where when you analyze the test results. If additional cooling is required, you can connect the built-in cooler using the power supply or use an additional fan. In the menu, select lithium and the charging process. Choose the maximum current. With lithium, we start the charging procedure at the first step. We set the maximum voltage. The capacity of the cell is clear here. The discharge procedure is simple. The settings are also clear. Here we set the maximum discharge current, the discharged battery voltage and the discharge current. So we won't go into that now. The cyclic test is also clear. There are 5 steps, not 9. And we also stop at discharge. But now we will show you how to balance a lithium-ion battery. Go to the settings, set the parameters. The best balancing voltage for lithium cells is 3.9 to 4.2 volts. The current remains standard. The voltage difference is 0, of course. The balancing current can be set to maximum, but a small one is even useful. It balances the battery more accurately. The tester uses active battery balancing and brings them to an overall equal voltage. After balancing the batteries, the difference in voltage between the cells should not exceed 10 to 50 millivolts, depending on the car model. After all the procedures, we connect a USB flash drive to a tester. At this time, it switches to another mode. We see the following. You will also be able to download updates for the tester, which we regularly release. Download the files saved in the tester to a USB stick. Insert it into computer. Find the file and open it in a special program that comes with the tester. The tester records data every second, so you can see it all in the table. We are most interested in the last battery discharge to analyze. Let's look at the charge. Each cell is highlighted with a different color, so it's very clear and simple. The graphs show where we have other indicators. Here we see which cells were charged smoothly and gradually. Some charged quickly and dropped in voltage. The discharge process is also well demonstrated. You can see everything step by step. We can immediately see the ones that work well. Everything is linear. Here you can see everything by channel in the table and separately. But the most important graphic is the cell health indicator. Here we can immediately see which cells are working properly and which are already degraded. All data is displayed in the report. You can even put your company name and logo in the area where you enter the name of your company and show it to the client. That is, we can replace defective cells here. And remember, before installing in the car, the nickel is fully charged and placed. Lithium needs to be balanced before installation. We can highlight the main advantages. The MS800 works with all types of batteries from hybrid and electric cars, has an automatic mode, saves test data, has integrated battery module protection, allows you to detect only damaged modules, and allows you to repair the battery instead of replacing it completely.